Okay, so we're looking at a binomial random variable situation here. How do I know it's binomial? Because there's two events. In this case, his score is above 200, or it's not. And each one of these times he bowls is independent of all the others, so therefore it satisfies the binomial random variable. In this event, we have 10 total games that he's playing, so that's my total number. The number of successes in this case is he wants to have at least 9 games. So he wants to have exactly 9 games that have over 200, and he wants to have exactly 10 games that have over 200. So at least means you go from the given number up to the total maximum number of events that we're talking about. So there's a total of 10 events. He wants at least 9, so that means he wants to have success in 9 and then success in 10. So I'm going to do this calculation twice correspondingly. Point 0.8 is the probability that he scores over 200 when he's bowling, and then failure in any math situation is always 1 minus probability of success. So success is 0.8. So 1 minus 0.8 will be 0.2. And then my exponent on the failure is 10 minus the total number of successes, and the total number of successes is 9. And then we'll do the calculation again, and we'll do it for 10. So this is a combination right here, and then these are just some exponent situation here. I'll also do it with the graphing calculator at the end. So we have total number of events is 10. We're looking for 9 of his games to be over 200, and the probability of having over 200 is 8. And the probability of not having over 200 is 0.2, which is just failure. So I get this number, these two numbers correspond, probability of success and the number of successes that he wants. And then this number here is just 10 minus 9, which is 1, or you can just do 9 plus 1, which is total number of events. I'm just going to repeat this calculation, but in this time it's the 10th game, so he wants to get over 200 and then in 9 games as well as in 10 games. So that would be 0.8 raised to the 10th because these two numbers correspond, and the probability of failure is 0. He doesn't want to get below 200. So notice 10 minus 0 is equal to this number here, or 10 minus 10 is also that number right there. So if I add those up, I get 3758. So that's the probability that at least in 9 of his next 10 games he gets over 200. If he gets 80% of the time, he gets over 200 pins. Looking at the graphing calculator situation, let me slide that over. So to get to, if I'm doing multiple events, you want to use, and it's a binomial situation, you want to use binomial CDF as opposed to PDF. PDF is just one individual event. So if I just did this one of these calculations right here, this one or this one, I would just use PDF. If I'm using a number of different events, it would do CDF, which is cumulative distribution, as opposed to P is probability distribution. It's not really helpful, but the C kind of helps with the cumulative. So again, so depending on your operating system, if it's the old operating system, you just put a bunch of commas in. So you just do 10 comma the probability of success, which is 0.8 comma, so 10 is the total number of events, probability of success comma the number of successes that you want, which in this case is 9. So what this does is what CDF does is takes this number and goes all the way down to 0. So we don't want that. We want to actually calculate 9 and 10 only. We don't want to do 9 down to 0. So we want to do the complement of that. So I'm going to throw in right in front of here, if I can get it to work. Oh, let's do the arrows here. So I'm going to insert a 1 minus. So now what this says is this is all of the events after 9. Because this is the 1 is the total number of events, just like in probability 1. This is a probability calculation here. That blinking is kind of bothering me. So if you do 1 minus 9, I'm going to get the complement of that, which is just 10. So I want to put 8 here. The complement of 8 events is, so BCDF does 0 through 8. If I do 1 minus that, I get the 9th and the 10th event, which is what I want. So if I calculate that, I get 3758, which is still letter C. And when I did this out the long way, I got 3758, which is also the same. So there's my answer, letter C.